Good morning, my dear students, and welcome to the world of electronics. Our lesson for today is taken from lesson 2 of module 1 under LX123, which is semiconductor devices. The lesson tackles all about transistors. These transistors are the bipolar transistor and unipolar transistor. Bipolar transistor has two types. These are the bipolar junction transistor NPN type and the bipolar junction transistor PNP type. Meanwhile, unipolar transistor has two classifications. These are the junction field effect transistor and the metal oxide semiconductor field effect transistor. Junction field effect transistor has two channels. These are the junction field effect transistor N channel and the junction field effect transistor P channel. On the other hand, MOSFET has two types also. We have the MOSFET depletion type and the MOSFET enhancement type. Under MOSFET depletion type, there are two channels also. We have the MOSFET depletion type N channel and the MOSFET depletion type P channel. Meanwhile, MOSFET enhancement type has two channels also. We have the MOSFET enhancement type N channel and the MOSFET enhancement type P channel. Then, there are advanced version of MOSFET also. We have here the dual gate MOSFET N channel and the dual gate MOSFET P channel. And lastly, we have here the combination of MOSFET and bipolar junction transistor, the insulated gate bipolar transistor or the IGBT. So, what are these transistors and how these transistors behave in electronic circuitries? Transistor class is a semiconductor device that has three electrodes. These are the base, collector, and emitter for a bipolar junction transistor. Then we have the gate, the drain, and the source for the field effect transistors. The term transistor is derived from a verb phrase, transfer resistor or transfer resistance. So what does it mean, class? Okay, let us find out. Let us have a simple circuit to explain this term, transfer resistance. Okay, let us assemble the circuit. We will use transistor, bipolar transistor, NPN type, bipolar junction transistor, NPN type, wherein the specification number is 2SD235, then the power rating is 25 watts. Then the bulb is connected here to the terminal of collector. We have here the collector, we have here the emitter, we have here the base for the bipolar junction transistor. And we have here the power supply. We will use this battery with a voltage of 9 volts. Okay, we have here a 9 volts, the symbol of battery. Okay, the bulb actually is connected in series with this emitter and collector junction. Okay, actually the bulb won't glow. It won't give light, although the battery is already applied to them. Why? Because the resistance between collector and emitter is very high. Okay, let us prove. We have here a transistor. Let us measure the resistance between collector and emitter. This one. At first, this is now the base and emitter. Then base, collector. Okay. The bulb actually is connected in series with these two terminals. We have here the collector and the emitter. So there is no resistance actually. The resistance is very high. Almost 20 million ohms or 20 mega ohms. That is why the bulb won't glow. Because the resistance here is very high. Current from this battery is being obstructed, being opposed by the higher resistance. So the bulb won't glow because there is no amount of current circulating from negative to this emitter of the transistor going to the collector, then to the bulb. There is no current actually because it is being opposed or obstructed by the resistance of emitter and collector. Actually, when we tested it, 20 mega ohms, the pointer doesn't deflect. Okay, the resistance is very high, but when the base is triggered, okay, if we connect resistor to the base from the positive side, one terminal of this resistor is connected to the positive side and the other terminal is connected to the base. So, there would be current flowing from emitter to base junction, then to this resistor going back to this positive side of the battery. If there is emitter base current, then the resistance of this collector and emitter will become very low. Okay, let us prove. And the bulb will glow. Okay, let us prove. Let us prove. Okay, connect the bulb here of this battery. Okay. The bulb glows because this resistor provides current path from this negative to this emitter base junction to this resistor. Without this resistor, if we disconnect this resistor from the circuit, so the bulb do not give light, or the bulb doesn't give light, because the resistance between emitter and collector is very high. But as soon as emitter base is provided with current by connecting this resistor here, there is a resistance of 680 kilo ohms, which is connected from the positive side of the battery to the base. So there is current flow here. So the resistance of collector and emitter junction is very low. That is why the bulb glows. The bulb glows. Meaning the resistance here becomes very low. So that explains the transfer resistance. The resistance transfers from the high resistance into low resistance. That is why we have the transistor. It is derived from that transfer resistor or transfer resistance. From that high resistance between collector and emitter junction becomes very low as soon as the base is provided with current when we connected the resistor. No? That really explains the transfer resistance. Okay. Transistor is said to be bipolar because bipolar junction transistor works with two charge carriers. These are the electrons as the negative charge and the holes as the positive charge, or just the same, because bipolar junction transistor works with minority carriers and the majority carriers. Okay, let us take this figure to explain further the behavior of the bipolar junction transistor as a bipolar. Actually, there are 3 layers of the transistor, unlike diode that has only 2 layers with 2 junctions. The layer of the emitter and collector, and at the center is the base. You can notice, class, that the base layer is thinner, masyadong manipis, compared to collector and emitter. That is the way how the transistor is designed, no? Then, in an NPN type, N means negative, P is positive. Emitter and collector are negatives, whereas base is positive. There are lots of electrons in this emitter because it is an N type. And collector has lots of electrons also. These are the majority carriers. Electrons here and here are majority. But there are minority carriers. There are few holes or the positive charge. But the positive type here, which is the base, majority are holes or the positive charge. and only lesser for the electrons. So, again and again, majority are electrons and minority are holes or positive charge. The same as here. But here, majority are holes or positive charge and minority are electrons. Okay. Emitter and base is always forward bias. So, negative of the power supply or battery is connected to the negative side of the emitter. Whereas base, positive, is connected to the base positive here. If this is silicon, there is a biasing voltage here of 0.5 to 0.7 volts as a biasing voltage for this emitter-base junction to put this transistor into active region. So it is forward bias. Current can flow through. So, destroying the barrier here. Current is freely flow here. But whereas, collector and base junction is reverse bias junction here. Because negative collector is connected to the positive side. And negative of the battery is connected to the base which is positive. So, reverse bias. So, majority carriers that is flowing here is electrons going to the protons here or holes. Whereas here, actually, that is the flow of the minority carriers because it is forward bias for the minority carriers. Holes are actually in correct polarity with the power supply here. So that there is still flow of minority carriers during this condition. So, bipolar junction transistor works with minority carriers and majority carriers. That's why bipolar junction transistor is noisy compared to unipolar. Actually, unipolar transistors such as field effect transistors are advanced version of transistors and they are less noisy because we have here the figure of the field effect transistor, junction, field effect transistor. The type is N-channel. N-channel, no? Because it goes like this. N-channel. So the symbol is here, N-channel. Meaning, the gate is positive. The gate is positive. Whereas the drain and the source are negative. Because the junction here, this is now the passage of the electrons. So drain corresponds to collector of bipolar junction transistor. And source is the emitter of the bipolar junction transistor. So, they are supplied with supply voltage, probably 12 volts for example. So, current would flow from this channel. The other term of channel is passage or path, daraanan ng kuryente. So, the amount of the current that flows here is controlled by the electric field. Because the gate actually is made of steel conductor. Naturally, when a voltage or a current is applied to this steel, there are electric fields. We call it spark that will be developed. So, if there is a lesser negative voltage, because this battery is variable, the voltage here is variable, meaning the current here is variable. When the voltage is variable, the current also is variable. When there is lesser negative bias voltage applied to the positive, so there would be bigger or larger amount of electric field. Larger amount of electric field, which will hinder the flow of the current. The current from source to drain is lesser. But if the voltage here is bigger negative voltage, so lesser electric field, bigger negative voltage, which will control the positive of this gate. So there would be lesser amount of electric field. In that case, there is a large amount of current. So The flow of the current here is only one. Either the flow of electrons, because N channel allows the negative current or the electrons to flow. But in the case of P channel, meaning the gate is negative, whereas the channel or the path for the current is positive. No? Just the same. More biasing voltage, meaning to say decreasing the electric field, or adjusting the voltage will increase the electric field. So the flow of the holes or the positive charge is controlled by the amount of electric field being varied by the external voltage. The external voltage here actually is the audio signal, the sound signal actually, that controls the current and the holes. In the case of the P channel, meaning to say the gate are negative, the channel is positive, meaning the flow of the holes. So there is only one flow of charge carrier, and that is the proton of the holes or the electrons. Unlike the bipolar junction resistors that are working with majority and minority. That's why they are called bipolar, because they work with two carriers, majority and majority carriers. Whereas here, only one carrier, either holes or electrons. Okay. Okay. Let us now come to the applications of this transistor. There are actually several important functions of this transistor. Transistor as a switch. Just like what we did a while ago, this circuit, transistor here, serves as a switch. Because it goes like this. Okay. When the base is forward biased, emitter base junction is forward biased. The collector emitter junction, the resistance there from high resistance becomes low. There is transfer of resistance. The bulb glows because there is a large amount of current circulating there. So, this is just a basic circuit of transistor as a switch. But actually, when we come to computers, digital watch, all electronic appliances today, or any electronic equipment that uses electronic circuits contain digital circuits. Actually, digital circuits contains transistors. Transistors there are used as switching transistors. No? You will know later on what is really this digital circuit, because there are two types of circuits. These are the analog circuit. We have heard the analog, and the digital circuit that are found in digital circuitry such as computers. Even the latest technology today like LED TV contains lots of switching transistors, no? That are located in this IC or integrated circuit. There are hundreds and thousands of switching transistors there. Okay, transistor, or just like this one, this electronic welding machine, Yamato brand, we call it IGBT, insulated gate bipolar transistor. Bipolar junction transistor there, the IGBT, actually used as a high-speed switching transistor. The output providing here at the two electrodes of this electronic welder, 300 amperes, very high. It is made possible by this high-speed switching transistor, the IGBT, combination of MOSFET and bipolar junction transistor. Transistors here are not used as amplifiers. They are used as a switch. High-speed switching transistor that turns on and off the current a millionth of a second. Meaning to say 100,000 hertz. 100,000 times on, turn on and off in 1 second. Just to provide higher amount of current at the output. And the power there is 18,500 watts, which will provide arcing at the two electrodes. Arc, no, which can melt the welding rod. Okay? Okay. Transistor as a switch. Transistors in computers are also applicable there, no? Okay. Transistor as an amplifier. AC signal from the microphone, for example, we have here. Okay. The microphone will serve as a source of audio signal. Okay, let us connect. We have here the positive. We will use oscilloscope. Okay. Positive here. And we will use alligator clip here. Negative for this terminal. Hello. Okay. Positive. Then negative. Positive, negative. Hello, mic test. Okay. Hello, hello, hello. Hello, mic test. This is now the audio signal. The sound wave coming out from my mouth when I talk against the microphone. When I talk against the microphone, the sound waves will be converted into electrical signal. Hello. This is now the electrical signal. Specifically the audio signal. No? Hello, mic test. When you shout, hi, hello, hello, the amplitude is getting higher. Meaning to say that the audio signal voltage there is higher. Okay, let us compute. Hello, mic test. Hello, how many centimeters? 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. 8 centimeters. That is the height of the amplitude. Okay? When you talk slower, hi, hello, I love you. So the amplitude is lesser. No? The amplitude varies in accordance with the sensitivity of your voice. Okay? So, we are using here 0.2. So, 0.2 times, we have here 8 centimeter times 0.2 per centimeter. 0.2 volts per centimeter. Centimeter and centimeter are cancelled out. What remains is the voltage. 8 times 0.2 is 1.6 volts. Hello? But that is the peak to peak. Only half of the cycle is being utilized. So, peak value divided by 2 is actually 0.8 volts is the peak value. But what is effective is actually 70.7% only of this 100% peak value. Because 0.8 is peak value 100%. But what is heard by our human ears is only 70.7%. So let us compute. 70.7% when this is converted into decimal number is 0.707. Then the peak value is 0.8. So 56, 56. 1, 2, 3, 4, 1, 2, 3, 4. So 0.565 or 566 round off. That is 0.566 volts or 566 millivolts. Hi, hello. This sensitivity provides the output of this microphone as 0.5. That is very low. It can be heard by your headphone only. The output of this phone plug of your microphone, you can hear the sound using your headphone. No? But the frequency, hello, 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 hello. The frequencies varies from 20 Hz to 20 kHz. The audio frequency range, when we say audio frequency range, the frequencies or the range of frequencies which are audible to the human ears. Below 20 Hz is no longer heard or it is no longer normal to the human ears. We call that frequencies as infrasonic. When we say infra means below sonic sound below the audible range. But above 20 kilohertz is no longer heard by the human ears, or it is no longer normal to the human ears, and we call it ultrasonic. Ultrasonic, okay? Above the audible range. Okay. So probably these frequencies varies from 1 kilohertz to 2 kilohertz because the voice frequencies of humans are really ranging from that frequencies. Okay? Guitar, cymbals, trumpet, the frequencies there are higher. Let us say 10 kilohertz to 15 kilohertz. But the drum, the frequencies there are lower. Let us say 20 hertz to 600 hertz. Okay? The frequencies varies for every now and then, as well as the amplitude. Okay? Low, low, low. Now, we can amplify. The term amplify means to increase, to enlarge the signal. Okay? Let us feed this. We have here an amplifier. We have here an amplifier, no? Okay, let us draw. Transistor as a switch. Transistor as an amplifier. Okay, we have here resistor over here. Resistor over here. Then we have here the capacitor. The capacitor. This is supplied with 9 volts. The 3 electrodes, emitter, base, collector, NPN type. Okay? This is now the input line. The AC signal or the sound signal is fed here to the base, and the output signal, which is amplified signal or enlarged signal, is taken at collector. Okay? We have here the circuit now based from this diagram. Okay? Okay, let us connect. Let us connect this negative side here. Okay? And the positive is connected here to the output. This is now the output line. The positive side of the oscilloscope is connected to this terminal of capacitor, whereas the black test rod or the black test probe of that oscilloscope is connected to the negative side. Okay? Then, the microphone now will be connected. The microphone will be connected here. Okay? We have here the positive connected to this input. Then the positive, the negative is connected here. Then we will connect this battery as the source voltage. Okay? Where's the other? We have here the positive here. The negative is over here. The negative is over here. Where is the? Okay. We have here the other alligator's clip. The positive is connected to the positive side of the amplifier circuit. Okay, we have here. Okay. Hello, hello, hello. Hello, my test. Okay? It is actually amplified. The signal at the output is amplified. The full plug is connected to the input of the circuit. The input line. No? We are connecting the microphone here. The signal 0.566 volts or 566 millivolt is actually fed here. Then the output is taken at collector, which is connected to the oscilloscope. You see that the signal amplitude is enlarged or amplified. Hello? See? Hello, my test. Hello, my test. Hello, my test. Okay? So the voltage there is higher. Let us say 8 centimeter times 0.5. So, bigger na. It is, hello mic test, around 1 volt. 1 volt. Sa input, the input is only 0.5 volts, but the output is 1 to 2 volts already. So amplified. That is the function of this transistor. Transistor as an amplifier. Transistor here as a switch. Okay? Then, transistor as a regulator. Actually, we have here a power supply. AC-DC regulated power supply. The output is unregulated. No? It is unregulated. Okay? The voltage output here is not regulated yet. Not regulated. But, once it is fed to the regulator, transistor as a regulator, we have here a basic circuit of regulator. Okay? We have here the output line of your power supply across this capacitor here, across this capacitor. No? That is 470 microfarad with a working voltage of 25 volts. Now, the regulator is connected here. We have here a transistor C1060, 25 watts again. Resistor 390 ohms is connected to the collector base junction. Then we have here a Zener diode. You notice that Zener diode is connected in reverse direction. The anode, which is positive, is actually connected to the negative side. No, with respect to the cathode, which is negative, connected to the positive side. Anode, positive, connected to the negative side. That is the way the Zener diode is connected. Because Zener diode will always operate normally at the reverse direction. Okay. Then, this is now the regulator. Zener voltage, we are using here 13 volts. Zener voltage, or the avalanche voltage of the Zener diode. The transistor here serves as a regulator. Transistor as a regulator. So, the output will always provide 13 volts based from the reference voltage provided by this Zener diode. So, if the voltage here is 16 volts at the output here should be 13 volts only. So, 3 volts will be here between collector and emitter. If the voltage here decreases to 15 volts, the voltage across collector and emitter will also decrease to 2. Because 2 plus 13, 15. If the voltage here increases to 18 volts, so this will be 5 volts. Because 5 plus 13 is 18 volts. So the voltage at the output will always retain 13 volts. Despite of the variation at the input. No? So the resistance here between emitter and collector varies for every now and then, in accordance with the variation of the voltage at the input outputted by the rectifier diodes. So, we have here. Okay, let us connect. We have here the regulator. Okay. We are actually connecting. We have here the negative side. Connect it here. Okay. There. And we have here the positive side. What is this here? Okay, positive collector. Let us see if there is voltage at the output. Okay. The voltage across here should be Probably this is K. Negative here. Negative of this capacitor is connected to this negative here. 11.6. Positive, we have here negative. Negative is over here. Positive is over here. So, 11.8 volts. That is not the regulated voltage. Actually, probably this general voltage is 12 volts. That provides almost 12 volts at the output. At least the transistor works as a regulator. The voltage at the output here, actually, if we are going to connect out to measure the voltage here, collector and the ground, is 16 volts. We have here 16 volts provided by the power supply circuit here at the output of the filter capacitor. The filter capacitor provides the peak value. That is the peak value. But once it enters the regulator circuit, because the regulator circuit will always provide a constant output voltage based from the Zener diode. So, it is outputted, the voltage outputted actually is around 11 point something. 11 point something. Probably this Zener voltage is, the Zener voltage is 11. 1N5241. Probably this is 1N5241. So whatever the Zener voltage will be the output also of this regulator circuit. The Zener voltage here serves as a reference. The regulator will vary its resistance between collector and emitter junction, no, to provide constant output voltage of this regulator. Okay, those are the important functions of transistors. Not only as a switch, not only as an amplifier, not only as a voltage regulator, but they are also used as a modulator, demodulator. So, demodulator and modulator will be discussed later on as we go along the series of activities. Okay?